Hey guys, welcome back to the shop. We have got a relatively small project to do today. I got a part here that belongs to a longtime friend of mine, Kenny. He lives here in town. We used to do a little bit of motorcycle riding together back in the day, back whenever we were all kind of part of I think it was called Pensacola Riders, group of guys that just liked riding motorcycles together back in the forum days before YouTube. But anyway, me and Kenny have stayed in touch for over the years, and he runs a local tire shop, which I go to whenever I need tires for the trailer. So he always helps me out there. Kenny is still into motorcycles. He actually really enjoys messing around with the Honda Grom. I know he's got a Honda Grom that he rides, and recently he has bought a Honda Ruckus. And I think he's doing a bunch of modifications to this Honda Ruckus. I think like extending the swing arm and doing all kind of custom things that guys like to do. So he's got this handlebar mount right here. I'm sure this is aftermarket as well. It's a really nice machined piece, all done on a CNC mill. But he said that he's got this little bracket that he wants to mount to this handlebar mount here. And I believe it's for a tachometer that he wants to mount on here. So he asked me, he goes, "You think you could mill that and drill and tap me a hole in there?" I said, highly likely that we can handle that and we can take care of it. So this is the bottom half, obviously. Your handlebar lays in there, 7/8 diameter handlebar, and you have the top clamp that goes on top of it right there. So that little blue line is a representation of this little metal bracket that's going to hold the tack, and he would like to put that right there. So what we need is a pocket milled in there, and then drill and tap a hole so that it can bolt down, and then that way this bracket and the bolt is not in the way of the top clamp that bolts down and holds the handlebar in place. All right, so a fairly simple job, right? Just mill a pocket, drill a hole, tap it, and you should be done. But the fact that this is sort of a U or V shape, should I say, adds a slight bit of complexity to it. Not anything that's hard to do. If I wanted to do this on the manual mill, I would most likely set up on the rotary table so that you can index this and mill it like we did on Tim's part here recently for his brake caliper. But in my case here today, I want to use my Milltronics, and this is a perfect job for the tool room mill. So I designed a little model. I didn't design the whole thing. We just did this top piece right here because that's all we're really concerned about. And I made a little model to represent the pocket that I wanted to machine in that. And we used Fusion to create a CAD program that we can use and put in our tool room mill and make this happen. So we're going to use the tool room mill, and we're going to get this simple little job done, nice and easy, and I'm ready to get started on it. So I'll give you a little rundown of what the Fusion program is going to look like. And then I need to get the mill set up. We need to get a vise on there. Since this is a nice machined piece, we can just simply clamp that in a milling vise, probe it, find the center of it, find the top of it, and then mill that little pocket in there that we need. Easy as cake right there. I did find I've got some of these little button head stainless steel bolts. So I found this in a stainless steel washer. We're going to use a 1/4 bolt because that's what I've got. I believe this is drilled so that you can use an 8mm bolt, but I've got this one, so that's what we're going to use. All right, so it's going to bolt on there just like that, and that'll take so we'll need to sink the pocket down 275 thousandths deep so that it clears the top clamp on top of that. And I'm sure there's a little bit of a gap in here too once you clamp that down. But anyway, that's the depth that we're going to take the pocket. So we'll show you the program, and then we're going to go get the mill set up and get this little part machined and get it finished up for Kenny. All right, guys, we got you at the computer here. I thought I would give you a rundown of the program in Fusion. And maybe this time we'll go ahead and show the modeling aspect of it. This is the manufacturer side where it's going to be doing the machine work. So let's jump back into design. And down here at the bottom, we've got our timeline of our sketches and our extrusions and holes and things like that. So maybe this is helpful to some of you guys. Keep in mind, I'm still new at this stuff and I'm learning this, and that's why I use Kevin all the time to help me with this. So like this design right here, I came in here and I designed this, and I got it really close, and then I had him jump on and he went over it with me, and he pointed a couple things out that we could have done a little bit better, improved it. I made some adjustments, and then we got it there. But this is a relatively simple part. So The part itself, keep in mind, I'm only designing the top of it because really all I care about is the width, the length, and the thickness of it, or this top height right there. So I'm not worried about everything that's underneath that. All right, but what we started with is basically a rectangle. You know, I'm going to show this. We'll go to Edit Sketch. And I just started with a basic rectangle and gave it the dimensions. And I actually used millimeters because this is all metric. It was machined in metric dimensions. All right, made a sketch. And next up, you know, we took and we extruded that sketch. Let me go to a isometric view right there. So the part was 23 millimeters thick, or it is. So I just extruded it up 23 millimeters and made it the thickness. And then the next thing we did was I created a sketch on this face, dropped a hole diameter on there of 875, which is the diameter of the handlebars, 7/8. And then once we put that hole circle on there, next up, we just did the, let's see, it was this extrusion right there. Edit feature. So I just extruded that hole all the way over here on the extent type, went all the way. And once you do that, it just cuts that hole out of there. All right. The next one, this is the one that was a little bit more tricky for me, but we got it figured out. So dropped a sketch here on this surface. All right, put a point on there, created a hole based off of the radius that I wanted on that bracket that's going to be mounted on there. And that bracket radius measures 5/16 or 0.312. So we put that radius on there, and then I added these lines right here, and then used the constraint to make everything nice and tight and pull everything together and constrained. And then so it created this sort of U shape in here that we wanted. Once we had that done, then it was simply just go into the extrude, and then extrude it down a negative 275 thousandths, and it just removes all that material. All right, and then next up was another sketch on top of this face after we extruded it, put a point on there so that we could put our hole location where we wanted it. And that's going to be this guy right here. We dimensioned our hole. I think I did a second sketch on that just to get that dimension the way I wanted. And then we created a hole. Created the hole that we want right there. We used this stuff over here to create the 1/4-20 hole that we wanted. And then we extruded the hole to the depth that we want. In our case, we're going to go 1/2 inch deep, 0.5. And if we come to the front, that's what's nice about these models. You can see where the bottom of the hole is and whether it's going to, you know, if you're going to come through the part or not. All right. So that was our hole we created. And then what was the next step right there? I'm trying to remember what this was. You know what? I don't remember what we did right there. I'm sorry. This is something that Kevin helped me with. But now I don't remember what that was. I think what we did, I'm sorry, we made a stock that represented the material that we were removing out of there. And that was just to kind of help aid in doing the cam work over here on this part. So that's just stock representing at the end of the design there. All right, so that once we had all this sketched up and ready to go, you go into manufacture, and we're going to be using 4 tools for this operation. All right, first thing we're going to use is a 1/4 inch 3-flute end mill, and we're running the 2D adaptive cycle, and that's going to rough out this profile of the slot that we need. And the next, it'll do a 2D contour to clean up the wall. We leave 10 thousandths, it's going to make one pass through there, clean the wall up. All right, then we're going to put in another tool. We're going to use a chamfer tool, and we're going to chamfer this top edge here, and then it's going to chamfer this bottom edge right here. All right, then we're going to spot it. So that same tool will do all this. We'll put a spot there for our hole. Next tool is going to be a number 7 drill, 0.201. And that's our tap size for 1/4-20. So we'll drill the hole. Then we're going to go in there with a 1/4-20 tap the hole, and then back in there with our chamfer mill so we can chamfer the hole. And then that'll be finished up there. So 4 tools and a relatively simple machining op that's going to be done. And what we're going to do to start with, instead of putting this in there and testing it on that, we just duplicated everything that we did here and pasted it. I call it test block, and I'm just going to take a piece of material, put in the vise. You know, we're going to use a piece of aluminum. I'll probe it in the center and off of this side right there. If we activate our test block, you can see our origin right here is actually lined up with this side wall here. So we'll just do a single surface and Y off of this surface, and it'll line it up with that edge, and then it'll know where to machine this. But for our actual workpiece, our Tach mount here, actually a handlebar mount, we're going to probe in the center, X and Y, and then Z off of that surface right there. So that's the only difference. So our test block will just be off to the side. So we're going to just put a piece of blank material in the vise and go through our test and make sure that I have everything correct. And if it all looks good, and it should, then we'll put our handlebar mount in there and machine that. So we'll get on out there to the mill and get started on this now. Last job that I just completed was I was using the magnetic vices. So we're going to go ahead and get our machine vise set back up. Just put one on here for now. Going on with the SP350. We'll get an indicator set up and get it trimmed. We'll use our steer-it test indicator for this one here. It's usually a little bit easier if you just kind of pry that open a little bit. It seems to be pretty tight on those dovetails. All right. Oh, I'm all the way forward. I need to take this back some. Try that. All right. Quite a ways off. All right, I can get my soft blow. Looks like about 2/10. I'm going to go with that. That is 2/10, so we'll go ahead and snug those. Now let's give it another check. Looks like 2/10 to me. Close enough for the work that we're doing. All right, let's take it in Z. Oh. All right, we got our vise trimmed in there now. I was going to show you the tools that we're going to use. This tool is that's our 1/4 inch 3 flute end mill right there. Tool number 3, and this one stays in the mill, but I pulled it out just so that you guys could see what we're going to be using. Tool 34. These are all going to be, these 3 are going to be hand loaded. Because again, I don't want to take the tools out of the turn in there. I just want to leave it in the tool changer, the ones that are in there. So tool 34 is going to be our 1/4 inch chamfer tool there. And then tool 35 is going to be our number 7 tap drill. And then tool number 38, it was already numbered 38, that's why we're using these numbers here. This is our 1/4 20 tap right there. This is the micro float by Technics. This allows for a slight amount of misalignment in the machine, so it should work pretty well. And we've already got all these touched off. They are ready to go. So here's a sample piece of material that we're going to use just to test it. This is one of the cutoffs of our material that we use for our drill indexes. So I got a few of these stacked up. It's a perfect material to test on. So we'll put this in there. We're going to probe it, find our edge, find our center, and we'll test it on this and see how it goes. All right, we'll call up tool 99, put our probe in there, and find our center. Putting our tool number 3 away back in the carousel. Now it's asking to install our tool 99, which is our Renishaw. Wrong side. There we go. To a reset, cycle start. All right, we are ready to hand wheel now. I'm gonna grab my pendant and just use that. All right, I believe that's 3 1/2. We just want to find about the center, so 1 3/4. All right, how long is this? All right, so let's find the center of that, there and about. Something like that right there. All right, we're just going to find X center for now. All right, that's our X center. I'm going to go ahead and just do Z now. We want single surface, Z, G54. Let's go a negative 0.3 to the part. And then Z position is 0. Run, cycle start. All right, it's saying that my battery is low. Press continue, cycle start to continue. Program stop encountered. The spindle probe battery is low. All right, well, one thing always leads to another, right? A simple project that's gonna take longer than it should. All right, let me see. I tried to keep some spares in the drawer here. Let me see if I got any more. And I think I do. Yep, all right. So takes a couple of these guys right here. So I'm gonna go ahead and take some time and change these batteries out since they're about dead. And then we can carry on with our program there. Let's see, cycle start to continue. No, we want to exit. We want to escape out of that. Hand wheel Z and bring that up. All right. All right, let's see if I remember how to do this. It was fairly easy. I remember right. Yep. This guy just slides out of here. And there's your two batteries. Let's do one at a time, make sure I get them in there right. There's your plus and minus. Yep, that's why it's it pays off to have some of these in the cabinet. Luckily we got the battery source right down the road, so they have these on the shelf. Put that one out of our way. Be the negative side. Negative side there. It's going to go this way in there. Okay, easy as that. Now what I'll do here, I put this on the desk, and when I go out for lunch, I will go ahead and swing by battery source and grab a couple more of these and put them in the box so that we got them for the next time it fails on us. All right, that was an easy fix. Back on task. Come on out of there. All right, back on track. We'll go ahead and bring it over and wire closer to the surface we're going to actually be machining on. And we want to do our single surface again. Z, G54, distance to part. I'm going to say negative 0.250. We want Z to be 0. All right, let's give that another try. Cycle start. All right, it's working. Okay, now let's go ahead, bring it over here. All right, we're going to do a single surface again in y-axis, distance to part. We're going to be going negative, I think, negative 0.250. Y position, we want 0. Run and cycle start. Nope, I went the wrong way. I always get them backwards. Cycle start. All right, so let me just come back in here. Oh, I know, it didn't like what I did here. Probe, distance to part, positive 0.250. Y position 0. And now we want to hit run and cycle start. Let's try it again. There we go. Okay, we are where we want to be for our test block. Very gently get our probe up out of here, out of the way. All right, we'll put this guy away where it's safe. All right, I think we're ready to run our program. One of the things I usually do before I start my program, I like to know that the coolant is going to be where it needs to be. So we've got our first end mill loaded up there, our first cutter we're going to use. And I just go ahead and do this. We'll use that one on the back right there. I was going to try to make it so that it's a little bit easier to see this, but I still want to use some coolant. You know, it either sprays where you want it, or to one side or the other of where you want it. That's what I was trying to say. Okay. So we know it's going to get the end mill there. And then, so what I'm gonna do is a tool change. And I wanna put my, my drill bit in there. So we'll do a tool change to number 35, T35 M6 run. There's our drill, and then tool reset, cycle start. All right, flood coolant. Oh yeah, that's great. Coming right down there on the drill where we want to. And turn that off. And then what I'll do is just, instead of doing a tool change, we'll just put our tap in there. That's going to get all over the tool body. That one hole, you know, we may just grab a little of our anchor lube and put a little dab on the hole whenever we go to tap it, before we tap the hole. That's probably what we'll do. Y'all remind me before we get there to do that. All right, guys, I think we're ready to start this. We're going to take it nice and easy so I don't crash anything. I mean, kind of bring it down slow, should I say. I'm going to turn the coolant off for now just so I can see everything. Seems like it's right on the edge. I'm just going to bring it down very slow. It seems like it's on the edge. All right, well, let's go for it. I should have put the, made like an extension where it's coming off of it a little bit. That's 50%, by the way. This would be our contour. All right, perfect. So we got an optional stop here, and I'm going to go ahead and optional stop it. I'm going to go ahead and check the bracket and see if it fits. All right, before we change the tool, we're going to test our bracket. All right, here's our bracket there. And I can tell that the width of this out here, I made it slightly a little too narrow. So I'm going to go back into our program. This is another reason why we're testing it. I'm going to widen this out a little bit so that it's not hitting here on the side of the bracket. I thought I had it really, really close, but you know, I was sitting it onto the actual workpiece and measuring it with calipers, and it looks like I'm slightly out just a little bit. So I'm going to make a modification to that, reload the program, and then we'll recut this again. I thought you guys might like to see this right here. One of the beauties of using Fusion is being able to just make easy modifications like what we're doing. So we're going to go back to the design. All right, let's bring it around to the front side so we can see that. And then what I want to work on is this right here. So I'm trying to find it in a timeline. Click that, you can see the little squigglies on the extrusion. So the sketch before that, this guy, should be what we want. So we're going to edit that. And then you can see my dimension right there, 0.781. And I measured it, and I thought I brought my calipers in here, but I did not. I measured it, and I'm going to make it 855. So we're just going to double click that, and then it highlighted it there. You can see 0.855, enter. It automatically just made that wider right there. I think that's going to work, so we'll finish our sketch. Now we're going to go back into manufacturer, and you have to regenerate everything. because we made a change. So I'll just come up here to my setup, right click and hit generate. And in a second, all these are going to start regenerating and turning green again. There we go. Okay, good to go. All right, so now what we can do is our NC programs. It should have been the first one that I did here. I'm just going to go edit. Yep, Tach mount test, and I'm going to post. Overwrite it. We want to overwrite that file. Yes. There it spits out the G code, and we're ready to go and load it back in the machine. Okay, let's give this another try. I've got the program reloaded again. I'm going to turn that coolant back off. Go ahead and let it do the tool change, and we'll check it again. All right, let me go ahead and test it now. Much better. Awesome. I think that's going to work this time. So let's carry on with our machining. It wants tool number 34. It's going to be our chamfer tool here. And we're just going to keep going with it, all right? Tool reset, cycle start. Getting up to 8,000 RPM here. Just going to run it slow. The feed rate anyway. That's just a 5/1000 chamfer break on that edge there. Not very much. 5/1000 on this front edge. Spot. Okay. Cycle start. I did not adjust the RPM to match on those two programs there. Tool number 35. Cycle start now. Hundred thousands to go. All right. Oh, it's making a mess. Let's turn that off. Cycle start. Because of that slow feed, we made a helicopter there and it slung that coolant everywhere. Okay, tool number 38. You gotta love that, don't you? Yeah. All right, tool number 38 is our tap. I'm gonna go behind the blast shield on this one right here. Oh, we were gonna put some anchor lube on there. I'm glad you reminded me. Get rid of that coolant out of the way. Go a little bit of our anchor lube. Like that. Now we can hit cycle start. You can see that I messed up and I had coolant engaged on that tapping cycle, so that was another little mistake I made in the programming right there. All right, so it wants tool number 34, which is going to be our chamfer. Just like so. So we'll reset. I don't want coolant. I don't want it on it because I want to be able to see where that cutter's at. All right, we got it. Let's see if our hard work paid off. It looks like it's fitting in there nicely. Let me grab the bolt. It's going in there, and it even tightens up. I think we got a winner there. It's actually fitting like it was machined for it. Nice and rigid. All right, I like it. I think that's gonna work well. I like it so much, I think I wanna cut it one more time before we put the actual workpiece in there. That is the downfall of only doing like one thing, is that, you know, once you get all this hard work done and everything's set up and your tools, everything right, you make a cut, which only, you know, it only takes a couple of minutes for something like this, and then you're done. So I think I'm just going to flip the block around and go ahead and I'm just going to go through this one more time just for fun. I could just shift it down and just do it there, but I think we'll just flip it around, and I want to do it one more time with full rapids, and I'm going to make an adjustment on my coolant and RPM and stuff like that, and just do that one more time. Okay, I made a few minor edits to the program. I think this is going to work a little bit better. The only thing we're going to run flow coolant on is the end mill at the very beginning, and for the drill and the tap, I'm just going to use my anchor loop there. So I just shifted the block down a little ways. I know we can recut it right there. So I want to go through this one more time and just kind of see it without slowing everything down and see how it's going to work. All right, so let's get going on it. I just run it down there like that so I can line up the camera so you guys can see it a little bit better. But we're going to reset and start now. Going with our drill, put a little anchor loop on here for that. Now our tap, another little shot of anchor lube here. Chamfer tool. All right, in the program. That took 2 minutes and 40 seconds. I'm happy with it. I think those modifications worked good. Got a nice looking sample part there. So, all right, next up, we'll go ahead and get our actual workpiece in here and get started on that. All right, let's get our workpiece set in here and get this job finished up. Should be able to set it right there on those built-in steps. Okay, that's tightened up. So we're going to find the center in X, we're going to find the center in Y, and then the top is our Z, because our model that we made for our actual workpiece is located, our origin is in the center of that. On our test sample, we had it off this edge there. We're going to go ahead and get this guy centered up. We'll start with our X, find the center. All right, now we're going to find Z0 on the top. Okay, now we got Y to do. I'm going to have to do this one a little bit different. I'm going to use web. Go ahead and try to find about the center of it here. Pretty close right there. For this, we're going to use web, y-axis, and just do our additional probing depth. I got it set to 9/16 or 562. Since there's this slot in the middle of that, we can't come down and let it touch the center. So let's give this a shot. Worked beautifully. Take it out of there nice and easy. Okay, I think we're ready to start working on this. I'm planning on going through it at pretty much full speed with the exception of when we start. We're going to bring our cutter down nice and slow and just make sure that we're in the right location in Y right there. Otherwise, I think we're good to go. All right, I think we're good. We're going to go ahead and turn the coolant on and let it rip. Chamfer tool. Number 7 tap drill, a little bit of anchor lube. Going in with our 1/4-20 drill. Another spot of anchor lube here. Chamfer mill to cut a chamfer. There it is, that finishes it up. Took 3 minutes to do that. That looks good. Looks real good. Let's get our bracket, make sure that it bolts on there like it's supposed to. There it is. That turned out nice. That was a fun little job to do. I really enjoyed this one. Small part to machine, a little bit of CAD practice and testing and tuning. I think we did a good job there. Another little check we can do is with our rule, make sure that the bolt's not sticking up, and it's not. Everything's programmed in there just as we wanted it. I like it. It is time to get this guy out of here. Get the mill cleaned up. I'm sure Kenny's going to be excited to get his hands back on his on his mount here. We can get it all back together and get his tachometer mounted on there. Well, this little project is wrapped up, completed, and I'm happy with the outcome. As I said earlier, I actually really enjoyed this one. It was a lot of fun using just a little part like this that most machine shops don't want to mess with because it's really not worth their time. But I enjoy these little projects like this because it's fun practice for me for Fusion. I enjoy machining as not only as a career, as a hobby too, so I just enjoy doing the work. But it also provides a fun little video that I can share with you guys on the channel of machining parts like this. And it kind of shows a little bit of my learning curve of going through the CNC stuff and taking a relatively simple part that needs to be machined but would be a little bit more. It's not that it's hard to go to a manual mill and do this. We all know how to do that. You can clamp this in a rotary table and, you know, line up in the center and rotate it on an angle, cut one side, rotate it on it, you know. And that's how I would do it if I did not have my Milltronics CNC machines. But the Toolroom mill is perfect for jobs like this. That's really what it's made for, is not necessarily like, you know, high-end production, mass production, but just doing job shop stuff, you know, just every little thing that comes in the shop, whether it be one piece or 100 pieces or whatever, Toolroom mill is perfect for that. So I'm just real happy with the results. This turned out great. And I'm sure my buddy Kenny is gonna really be happy with the outcome of this, and he's gonna be ready to get it back on his Honda Ruckus. So I'll see if I can get a picture or two from him to throw in the video here so you guys can kind of see what his bike looks like and maybe what this looks like mounted up and everything. All right, so again, I hope you enjoyed the video, and I hope you enjoyed the project, and I hope you come back for the next one. All right, we'll see you guys then.